All right, Liberty North High School, AP and dual credit psychology. It is November 2nd, and this is a supplemental video to the lecture and the notes that we took last Thursday and Friday, which would have been October 29th and 30th. Okay, so this is a learning target 7B, which again talks about the neuron, neural transmission, neurotransmitter delivery, and so on and so forth. And specifically, it's asking, just have a basic understanding of how medication influences the transmission of neurotransmitters, okay? So this heavily deals with page 82. So there's a great chart on page 82 that you need to know that has a list of neurotransmitters, and then whether too much or not enough is involved in the different illnesses, everywhere from neurological, like Alzheimer's and Parkinson's, to psychological. So I talk about anxiety and depression, insomnia, so on and so forth, epilepsy. So after you get done watching this, make sure you turn or even have page 82 open. You can have it on the online text if you want, but make sure you go back and look at the chart on page 82 and read the text on page 83, okay? All right, so we're gonna get started up here, okay? And I'll stand to the side. I'll move this over here, okay? So what we have is there are two types of substances, medication that we can use to treat varying disorders in psychology and neurological disorders, okay? An agonist is anything that increases the neurotransmitters or chemicals in my body. So anything that increases the amount that I have or mimics it is going to be an agonist. Anything that decreases the amount of neurotransmitters or blocks it is going to be an antagonist, okay? So these are going to be the two types of medications I'm going to use to either increase certain neurotransmitters or decrease certain neurotransmitters, okay? So increasing them will be an agonist, decreasing them will be an antagonist, okay? Now, on number 7, okay, learning target number 7, we talked about when a neuron fires, okay, with its action potential, and it delivers neurotransmitters, 3 things happen in that synaptic gap. Okay, so once the neuron has that electro action potential travel through the neuron and it's going to fire, right? The first thing that happens is it has communication or reception of neurotransmitters. So it's going to fire and deliver its neurotransmitters into the synaptic gap, and then those are going to be received or communicated to the receiving neurons, okay, and at their dendrites. Okay. The next thing that's going to happen is the firing neuron, the neuron that fired the neurotransmitters into the gap, is then going to replenish, okay, its neurotransmitters. So as part of its refractory period, its recharge period, it's going to suck back up the neurotransmitters it has fired to help replenish it, okay, to restore it, to re-energize it, if you will, okay? And then lastly, under normal circumstances, a neuron will not fire if the synaptic gap has neurotransmitters or proteins or anything in it. So enzymes will then sweep into the synaptic gap and clean it out. And then once the gap is clear, the neuron will be ready to fire again. The refractory period will be over and it will fire again, okay? Now, also make sure that you know this happens on a neural network level. Okay, so if you turn back to page 80, you'll see the serotonin track and the dopamine track. Okay, and so on these track are our neurotransmitters that produce those chemicals, those substances, those neurotransmitters. Okay, so if I'm increasing serotonin, it's going to work on all the serotonin neurotransmitters throughout the track. If I'm trying to increase dopamine, it's going to work on all the dopamine neurotransmitters on the track. Okay, so when I do this, I'm not impacting just one neuron. Again, neurons function in networks, not individually. Again, each neuron has thousands of connections with other neurons. So it definitely passes the signal along, okay? All right, now, since these are the 3 things that happen, these are the 3 mechanisms that I can then work on or manipulate or change in the brain chemistry to help individuals who need more of a neurotransmitter or less, okay? So if I want to increase the neurotransmitter, I'm going to be on this side, okay? So I'm going to increase communication and reception. I'll decrease reuptake and decrease enzyme digestion. If I want to decrease, perform the antagonist mechanism, I'm going to decrease reception and communication, increase reuptake, and increase enzyme digestion. Okay. All right. So I could do any of the three. I could do two of the three. I could do three of the three. The general rule is that if I just work on one, I'm not going to have as many side effects possibly. Okay. So, you know, we look on page 82 and look under dopamine. Okay. All right. And you're going to see two disorders there. If I have too much dopamine, I'm going to have schizophrenia. If I have a lack or an undersupply of dopamine, I can have Parkinson's. Okay. All right. So Parkinson's is going to be given an agonist for dopamine because we need to increase it because there's an undersupply. Schizophrenia and psychosis is going to be given an antagonist because they have too much dopamine. So we have antipsychotic and Parkinsonian medication. Okay. Now with Parkinson's, generally it's going to be mechanism number one. I'm going to increase the amount of dopamine in the brain by giving the brain synthetic dopamine like L-DOPA, levodopa, cardiadopa. I'm going to give the brain, okay, more dopamine so it can communicate and receive more. Okay. All right. Okay. Now, I could also decrease reuptake and decrease enzyme digestion to do that. So when the neurons fire dopamine into the gap, I can block reuptake. So the sending cell then doesn't replenish the dopamine as fast or as strong, and enzymes don't come into the gap and digest as fast as strong. That way, that leaves more dopamine in the synaptic gap to be passed on. Okay, so again, don't just think at a single cell level, but think in a neural network level. So if all the cells in the network are doing that, overall, that increases my dopamine and it makes it more likely that it's going to be communicated and passed on. Okay. All right. Now, if I want to cut back the dopamine, okay, because of antipsychotics, then I can just decrease the reception and communication. I could block it. I can then increase reuptake, okay, because the more the cell replenishes or sucks back up, the less there is in the gap. And same thing with enzyme digestion. The more enzyme digestion there is, the less dopamine there is in the gap. Am I saying that right? Hold on. Reuptake. Yeah. So I'm lowering it. So there's less dopamine in the gap, which means there's less to be communicated. Okay. Okay. Now, the big example that we talk about in class, also which the book talks about, is SSRIs, which are selective serotonin reuptake inhibitors. Okay. I think they're probably the most prescribed medication that we use today for antidepressants. Okay. And they work on this mechanism right here. Okay. So in the name of the drug, it tells you what it does. So it's a selective serotonin, that's the neurotransmitter, reuptake inhibitor. Okay. All right. So what's going to happen is if I take an SSRI, it's going to actually increase my serotonin. It's an agonist by inhibiting or lowering or blocking reuptake. Okay. So those are going to be medications like Lexapro, Prozac, Zoloft. Okay. Those are going to be your kind of most popular drugs, most useful drugs today. All right. And they all work on that principle with serotonin. They're going to decrease reuptake. Right. So by decreasing reuptake, I'm actually increasing serotonin in the brain in those networks that produce serotonin on that serotonin track. And that's an agonist. Okay. Now, if my SSRIs don't work, I can then go to SSNRIs, which the book mentions. Okay. Which then works on the reuptake principle mechanism for not only serotonin, but also for norepinephrine. So it's a selective serotonin norepinephrine reuptake inhibitor. Okay. So I'm going to increase, as the book does, both serotonin and norepinephrine, right, as they're both chemicals and neurotransmitters involved in depression, by lowering or blocking or reducing reuptake, which then again is going to increase the overall levels of serotonin and norepinephrine in the gap to be communicated and passed on. Okay. All right. So again, you're going to have to do this on your quiz. So I'll give you a disorder that's listed on page 82. So make sure you look at page 82 and you know those neurotransmitters, all right, and you know what they're involved in, okay? But I'll give you one from page 82. So let's say I give you Parkinson's. So I'll tell you, okay, identify in the neurological disorder of Parkinson's, what is the neurotransmitter involved, Okay. Is the issue too much or not enough? And then how would I correct that? Should I give an agonist or an antagonist? Okay. And then which mechanism, you have to pick one that you would work it. Okay. That the medication would work on. So let's say I was doing Parkinson's. Okay. So I'd say, okay, which neurotransmitter is involved in the disorder? You'd say dopamine, and it's a lack of dopamine. Okay. So they're going to need an agonist then. We need to increase it. How would you increase it? You can do what we talked about. I'm going to do mechanism number one. I'm going to give them synthetic dopamine, or just give them medication that increases the communication and reception of dopamine. Okay. All right. If I ask you for serotonin or depression, then you could say, okay, the neurotransmitter is serotonin. They don't have enough of it. They're going to need an agonist, and I'm going to do reuptake. Okay. So I'm going to do the SSRI. I'm going to lower reuptake so that it increases serotonin. Okay. So make sure you know the chart. Okay. If you have any questions, email me, chat me, just let me know. I know this is for Kamryn. This is for you. So if you need anything else, just let me know. Hope you're feeling better. Hope you're recovering. Okay.